All right, this video will make a shaft cooler, which is like a bolts which can put on both end of the shaft from sliding. Okay, let's go right to it. We can once again we can go to different ways to start a new part. Just click new. Once again, this will bring up to the template. You can click part. Once again, make sure it's inch per second. If it's not, and you can go to Tools, Options, Document Property, ANSI, Unit. Make sure inch per second. Also make sure you have 3 decimal places, and click OK. So this set up the drawing environment for us. For this one, I'm going to choose front plan, make a sketch. First one, I want to draw a circle. Make sure the center of the circle snap to the origin. Move cursor a little bit away. Anyway, okay, once again, if you see the bottom status bar, it says undefined because we did not give exact diameter of the circle. Click Smart Dimension. Click anywhere on the circumference. The diameter for this one actually is 0.4375. 0.4375. Remember, we only choose 3 decimal places. If you input 4, it will automatically run up. Okay, once that's done, you can click Enter. So it gives you 0.438 because we only choose 3 decimal places. Most of cases, 3 decimal should be plenty. Now, if you notice the status bar, it says fully defined. Now we go to Feature, click Extruded Base. Okay, for this one, I want to choose once again choose the middle plane. Choose the direction 1, middle plane. That is to ensure the origin is in the middle of this axle shaft cooler, and the depth should be 0.25. That's the shaft. So the total is 0.25 from the middle plane. So middle plane right in the middle. So click this green check. So we finish our cylinder essentially. Now I need to drill a hole right in the middle. So what I'm going to do is this way. Okay, look at here we have 3 surfaces we created. I want to click this front surface. Now the front surface turned into blue. I'm going to click the sketch right here. That means I'm going to make a sketch on the front surface. The surface is we just created, not on the front plane. Of course, this front surface is parallel to the front plane. Okay, make circle. Make sure once again the center snap to the origin. Move cursor a little bit away. Okay, use your Smart Dimension. Click anywhere on the circumference. And for this one, the diameter actually is 0.190. Okay, now that it is fully defined because we give a center, we give diameter, it's fully defined. Now we're going to click Feature. For this one, I'm going to choose Extruded Cut because I want to cut a hole which the axle can be put through. Okay, for this one, direction one, I want to make sure that it's through all. So that means no matter how the depth of the color is going to cut through. Now click this green check. Now that is, if you click your middle wheel of your mouse and hold to it, now it rotate. You will notice that this object is a through hole. Okay. Now that is, we can do a little bit investigation. Okay, we make this color. If you notice that is a material, I want to click this material. Right click, edit the material. We can choose a material for this color. For instance, for this one, or you have a bunch of material to choose. So you have a steel, you have a different type of steel. Also, you have iron, you have aluminum alloy, you have a copper alloy. Let's just choose copper. Let's click this copper. Let's choose the basic copper, okay? Okay, that is, if you notice, you choose the material, it has different properties such as the elastic modulus. You may have, Poisson ratio, shear modulus, density, so on and so forth. Okay, and click apply. Oops, click apply. Apparently, for some reason, it refused to apply that for me. Okay, I'm gonna click close. It did apply. It just forgot to close. So we make this color, and this is the simple way, to make object. And we set the materials. Now we do a little bit of investigation. If you click evaluate, and okay, we have a object with the exact dimension. We can do like how heavy this part would be. If you click over here, it actually shows the center of the origin, that is 0, 0, 0. That means the center, the origin is right in the middle. Okay. Also, it gave you, once again, that is the mass. The density of the copper is this much. The density of this object is this much. And the mass is 0.01 pounds. That also give the volume, give the surface area, give the center. That's essentially the physical property of this object. Okay. And also, if you want to click the surface of this cylindrical surface, if you double click that, if you notice that is some of the property we put in, it shows up right there. Remember the diameter 0.4375, also the thickness 0.25. If you remember that, right? Okay, now double click this one, 0.25. Oh, actually, if you notice that I put something wrong, that is 0.26. Actually, it should be 0.25. So now you can correct, for SolidWorks, it gives you opportunity for you to correct your own mistake. You fix that, click this green check. So 0.25. Once again, that is. Now if you, let's say, double click this one more time. Oh, 0.25 is not correct. It should be 0.5. Just correct it, become 0.5. Click enter. So it fixes the dimension accordingly. Okay. Now, of course, this is not right one. Should be 0.25. Just hit this undo. Should be 0.25. Okay. Let's save this file as. For this one, we're going to save it as a shaft. Cooler. Make sure you save into a correct. Rebuild and save the file. Okay. Oh, typically you want to put into isometric view. Click this one, that is the isometric view, and save it one more time. Okay,